Chapter 3.5 Communications between Neurons. The point of communication between two neurons is called the synapse. The message-sending neuron is referred to as the presynaptic neuron. The message-receiving neuron is called the postsynaptic neuron. The synaptic gap is the tiny fluid-filled space, only 5 millionths of an inch wide, between the axon terminal of one neuron and the dendrite of the adjoining neuron. Transmission of information between neurons occurs in one of two ways: electrical. Ion channels bridge the narrow gap between neurons. Communication is virtually instantaneous. And chemical. The presynaptic neuron creates a chemical substance, a neurotransmitter, that diffuses across the synaptic gap and is detected by the postsynaptic neuron. Over 99% of the synapses in the brain use chemical transmission. An action potential arrives at the axon terminals. These branches at the end of the axon contain tiny pouches or sacs called synaptic vesicles, which contain special chemical messengers called neurotransmitters. Synaptic vesicles release the neurotransmitters into the synaptic gap. Synaptic transmission is the process through which neurotransmitters are released by one neuron across the synaptic gap and affect surrounding neurons by attaching to receptor sites on their dendrites. After synaptic transmission, the following may occur. First is reuptake, the process by which neurotransmitter molecules detach from a postsynaptic neuron and reabsorbed by a presynaptic neuron so they can be recycled and used again. And secondly, there can be enzymatic destruction or breakdown. Each neurotransmitter has a chemically distinct different shape. For a neurotransmitter to affect a neuron, it must perfectly fit the receptor site. Excitatory and inhibitory messages. A neurotransmitter communicates either an excitatory message or an inhibitory message to a postsynaptic neuron. An excitatory message increases the likelihood that the neuron will activate. An inhibitory message decreases the likelihood that it will activate. The postsynaptic neuron will only depolarize if the net result is a sufficient number of excitatory messages. Depending on the receptor site to which it binds, the same neurotransmitter can have an inhibitory effect on one neuron and an excitatory effect on another neuron. On average, each neuron in the brain communicates directly with 1,000 other neurons.